Hello, let's continue our Sudoku adventure with Circular Reference by GDC. So this continues our Numbered Rooms theme week. I also want to point out that the Sudoku is just the white cells. It's what you'd expect. These are just gray to represent the outside clues because we're going to be able to fill digits into some of them. So the Sudoku is just here. So these can be the same digit, for example, because we don't have Sudoku rules on the outside. All right, I wanted to make sure I said that right at the start. Hopefully that's clear to you. But yeah, so we have normal Sudoku rules, numbered rooms, and counting circles. So let's go over all of these rules carefully. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. These clues outside the grid, including whatever we fill into the counting circles, are numbered rooms clues. So what that means is you take the digit that's next to the numbered room clue, say we put a 3 here, we now count 3 away from it. 1, 2, 3. We place that numbered room clue next to in that cell. So 3 would put a 4 there. 6 would put a 4 all the way down there. Now, for this clue here, say this was a 5. If this was a 3, we count 1, 2, 3 this way, placing the 5 there. If this was a 6, we count all the way over here, putting a 5 there. So it's from the clue. Okay, in addition to that, we have counting circles. If a digit appears in a counting circle, say a 3 appeared in a counting circle, that means exactly 3 of the counting circles have a 3 in them. So we could put a 3 here and a 3 here, for example, or a 3 here and a 3 here. But we can't, it would be exactly 3. So that means we can't put any more 3s in, and we must have exactly 3 of them be 3. So if a digit appears in a counting circle, it appears that many times. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right. There's a couple things I want to think about here that I haven't thought about fully, but the first thing I want to do is just mark up what these numbered room clues can be. Because unless your numbered room clue is a 1, you cannot put a 1 or itself next to itself. Let's talk about 1 first. If we put a 1 next to this 3, then that's telling us that in that cell, we're putting a 3. But there's already a 1 in there. So that's obviously no good. You also can't put itself, because if we try to put a 3 there, that's telling us that somewhere else in the row, there's also a 3. So that would be no good. So not 1 or itself. So if we put 1 through 6 in here, we can't be 1, we can't be 3. Okay, now these are the same numbered room clue as each other. We had this in a previous puzzle as well. We must use a 2 in one of these, because if we don't use the 2, these are both 4, 5, 6, telling us there's a 3 in here, and there's a 3 in here, putting 2 3s in this box and no 3s in this box, both of which are very bad. So we do use the 2 when it is going to put a 3 in one of these 2 cells. All right, this cell here is 1 through 6, but not 1 or 4. So 2, 3, 5, or 6. I guess I should mark that this can't be a 4 then. I guess that's the only way to really remember that best. All right, so that's all I get out of the numbered room clues as far as I can tell. There's a 3 in here or a 3 in here, which is not super exciting. All right, I want to think about the counting circles because it's kind of muddied by the fact that there's 3 outside of the grid. So normally, if we ignore these 3 outside the grid, which we can't, but let's say we did, I want to talk about the normal property of counting circles that I want to kind of expand on, which is that the sum of the unique digits equals the count of the circles. Because if you think about it, if you put a 1 into a circle, then exactly 1 circle is a 1. And so then that would, and if we put a 2 in the circle, then exactly 2 of the circles are a 2. And so if you sum up the unique digits, that's going to tell you how many circles are needed by those digits. So if we were to put, say, 1, 2, 3, 4 into these 4 cells, because we know we need at least 4 unique digits, that sums to 10. That's going to use exactly 10 cells. But that's muddied by the fact that, is that muddied by the fact that these are not in the grid? You know, I don't think it is. I think that's just a property that works, even though these are outside the grid. So what we can say is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 cells. And so the sum of the unique digits is 11. Interesting. Because we're going to be putting like those digits that many times each for itself. Yeah, and so it doesn't matter. And I think that the important bit here also is that these can't exceed 6 because they are numbered room clues. So, all right. That means that we are using only 4 unique digits. 5 unique digits add to at least 15. 1 through 5 is 15. So, in fact, there's only one way for 4 digits to add to 11, which is 1, 2, 3, 5. All right, so these are from all of our numbered room clues are 1, 2, 3, 5 only. So let's clean up the ones we already have marked. This can't be 4, 6. Basically, we don't put 4 or 6 in any of them. And so if these are 2, 5, these are 1, 3. And by the way, the reason I know, like, I kind of just know in 4 cells 11 is 1, 2, 3, 5 because I have that memorized at this point. But the way you can kind of logic that out is 1, 2, 3, 4 is the minimum, which adds to 10. So we need to add 1 to that sum in order to get to 11. But you can't just magically add 1 to it. You have to add 1 to one of the individual digits. And if we can't repeat any digits, like if I've got 1, 2, 3, 4, right? I need to add 1 to one of them. I can't add 1 to the 1 because there's already a 2. I can't add 1 to the 2 because there's already a 3. I can't add 1 to the 3 because there's already a 4. So I have to add 1 to the 4 to make it 5. And that's the only option. Okay, so that makes all of these 1, 2, 3, 5. But actually, none of these are 1s because we know that this 1, 3 pair has the 1 in it. So none of these can be a 1, which is helpful. So that's a 2, 3, 5 triple, meaning this is also a 2, 3, 5 triple, right? This is a 1, 4, 6 triple, meaning that this then has to be the 3 and this is the 1. Okay, we don't need these corner marks here. So the 5 is telling us there's a 3 in one of these two, which means there's not a 3 here or a 3 here. All right, this is flowing pretty well. This can't be 1. This is 4, 6. All right, so 4 is in 2, 3, or 5. I don't know what to do with that right now. Oh, we cannot put a 1 next to a non-1 numbered room clue, so that does put the 1 here. And that makes this a 1, 3 pair. And that makes this a 4, 6 pair, just based on where the 1 can go in the box. All right. What else is going on here? This numbered room clue places this. So these can't be the same digit as each other. I don't know what to do with that. We need a lot of 5s. Okay, how are we fulfilling all these 5s? One of these is a 5, definitely. And one of these is a 5, definitely. Can I make all of these a 5? I might be able to. Hold on, this is 1, 4, 6. So this places 2, 3, or 5. Right, this can't be 1, obviously. It places 2, 3, or 5 here or here. So if this was a 6, this would be a 3. I don't know if that's a problem. Let's see, I need to watch out for my counts here. This is a 2, 5 pair. So if this was a 2, this would also be a 2, and then we'd have no more 2s. But oh yeah, that's no good because there's a 2 in here. Right, okay, I know where 2s are. They're here and they're here. That's the easy way to put it. So none of these are 2s, which does actually make this a 5. Makes that a 2 and that a 5. Okay. By the way, our conflict checking is only kind of working because we have these outside things and the conflict checker gets confused. So it prefers to be confused in a way that doesn't conflict things that should, rather than, like, it doesn't want false positive conflicts. So it does the opposite. It's conservative. So this is a 2, 5 pair. Right, we don't want this 3 saying that this can't be a 3 in the conflict checker. Anyway, thought I'd explain that. And it uses the stored solution to know which rows and columns don't actually have repeated digits, so we shouldn't conflict check them. All right. Right. So there's a 5 here, there's a 5 here, there's a 5 here. So 2 of these are a 5. Can this be... Let's see, if this is a 4, this has to be 3 and 3. This is a 6, this would be 3 or 5. There's clearly something I'm not seeing here. So 2, 3. Oh, this can't be 5 because of Sudoku. I might miss some Sudoku because I don't have the red marks on some of these. So this can't be a 2 because it would put a 3 or a 5 there, which obviously isn't going to happen. So that means they're... Oh, okay. So yeah, this is a pair, a 3-5 pair, if you want to put it that way. But it puts a 3. It puts this digit here. Oh, okay. Yeah, that's no good. If this is a 3, this has to be the 5, putting a 5 there. But there's already a 5 in the row. So this is a 5, placing a 3 there. That's 2 and 3. Okay. So we have all our 3s. So these have to be the 5s. There we go. So we got all of our counting circle amounts. I'm glad that that counting circle property doesn't actually depend on them all being in the grid. It's interesting. So 5 is placed not in 6. 5 is placed in 4. That's 4 and 5 and 2. These are not 4s. 3 does place the 4 there, giving us 6 and 4 there. Okay. These are 4, 5, 6. Ah, the 5 is placed in 4 or 6, but it's not in 4. So that's 6, that's 5. That makes us 4, 6, and 4. Okay. This is a 2, 3 pair. And this 3 tells us that's 2 and 3. Okay. Almost there. I think it's Sudoku at this point. Did I miss any of the numbered room clues? I'm not sure, but let's just do as much Sudoku as we can. So this is 5, 6, so that's 6 and 5. Down here I need 1, 2, and 4. I'm going to fill that out. Let's clean it up. So this 4 sees down. This sees a 2. This sees a 4. Oh, this 6 looks up. That's 1 and 6. That's 2. 1 and 4. Okay, here we've got 1, 3, 4, 5. So we need 2, 6. This 6 tells us the order. Here I need a 1 and a 3. There must be a numbered rooms. Yeah, the numbered room is resolving the 3s. So this 2 puts a 3 there, and a 1, and a 3, and 1, and now we're done. Cool. Nice puzzle, GDC. I liked how that all worked out, where we got that 11 sum for the unique digits in the counting circles, which then forced quite a bit, which was interesting. All right. Well, I enjoyed that. Hope you did too. If you did, then why not leave a like, subscribe, and a kind comment below.